Okay, in this demonstration we are creating a 500 milliliter solution of saline. So we're going to fill this beaker up with 500 milliliters of basically salt water. Saline is salt water at a specific concentration. We have our balance, we have our sodium chloride. It's a little blurry there, but that's sodium chloride, which is basically the same thing as the salt that you put on your food. And we're going to measure out the appropriate amount that we need to make 500 milliliters of saline solution. And hopefully you've already done the math on this. If we need 0.9 grams of sodium chloride per 100 milliliters of water, then for 500 milliliters of water we just need to multiply by 5. So we need to measure out 4.5 milliliters or 4.5 grams of sodium chloride. And we want to try to be accurate on this. Once we've obtained the right amount of sodium chloride, we can add that to our beaker, fill it up to 500 milliliters, and that should give us 500 milliliters of saline. Okay, it looks like we're close enough. 4.50, maybe 4.51, but let's go with that. So we toss that into our beaker, and now we need to add water. This is our distilled water, and we want to bring the volume of that water up to 500 milliliters with the salt already added. And as you know, beakers are not the most accurate way to measure volumes, but in this case I think we can go with that. Okay, and you can see there the salt kind of sitting at the bottom, so we're going to have to mix that up a little bit, and that's filled to 500 milliliters. So we'll stir that up and get it to dissolve. And then we'll check and see what the density of that solution is using a hydrometer. Again, your lab manual tells you what the predicted density of saline should be, and we'll check and see if our solution is pretty close to that. And hopefully it will be. This is a hydrometer. We'll take a good look at that. Let's get the balance out of the way. A hydrometer is made up of a bulb, a glass bulb that has a stem with markings on it, and then a cylinder that looks kind of like a graduated cylinder without any graduations. So it's just a little glass cylinder. Okay, we're going to go ahead and add just distilled water to our cylinder and see what the density reading is with the hydrometer with plain water. As the lab manual describes, the density of water is exactly 1.0 if there's nothing mixed in with the water. And so we should see that. Now notice I've added enough water to get the little bulb to actually float. It's not resting on the bottom. You can see that. It's kind of bobbing up and down as I poke it. And what we want to do is try to get it so that it's not rubbing against the side as much as possible, and that's difficult to do, especially in a small hydrometer. But we want to try to see what the reading is, and although it's blurry, you can see that the stem is barely poking out of the water. And if you could read it, it would be right at 1.000. And we'll go ahead and dump that water out. And what we want to do now is compare that with our saline. Now, as you know from your lab manual, the specific gravity of saline, or density, is 1.0048. Our hydrometer doesn't have that fine of markings. It does go to thousandths, and we're going to see if we can see a difference here and get a reading. Okay, I've added enough saline for the hydrometer to be bobbing in the solution. It's not resting on the bottom. And I know it's very hard for you to see in the video, but there is a slight difference. The stem is sticking out a little bit further, and if you trust me to measure the specific gravity for you, I'll do that and give you the reading that I see. It's difficult to see, but it is about 1.005. And there we have it. Record that in your lab manual.